Hello, everybody, and welcome to Rational Science.
Hey guys.
Today we have a great day. First, I want to say that I was in London for the past couple days, so that's why I had to postpone the class. Hopefully, this Sunday will be normal. Okay, so let's get started here, and here's a rundown of what we're going to be doing today. Okay, I'm going to look at what is a concept. Okay, and I'm going to beat up a little bit on the electric universe, on the flat earthers, on the oh on the flat earthers, the flat universers, and there we have a definition of what all those words mean: idiocy, idiotic, idiopathic. Any of those, they it's got to do with the word idiot.
We got a lot of ideas.
Yeah, it's an individual with big ideas. See, when you have a normal idea, it's an idea. But when you have an idea, well, then we know that you have a big idea, and that's more or less where all these people stand. Okay, we're going to go with the science critic later on. Also, he's got big ideas as well. Okay, and finally, we're going to open the floor up for some questions and comments. First, the ones that people made since last time, and then whatever people asked today. Okay, so let's get started here. And before I can begin, let's begin at the beginning. Begin to begin. Begin to begin. Okay, so here it is. And a fellow says the following. He says, Bill spends half the time insulting his 7 loyal viewers. Not very compassionate. It's called gaslighting. No school would tolerate such behavior from a teacher. Uh-huh. And gaslighting comes from it was a play originally. Then they made a movie in Great Britain. Another one 4 years later in Hollywood. In fact, Ingrid Bergman won her her Oscar for Gaslight, and it has to do with a fellow who tries to drive his wife crazy to get some jewels and some money. Okay, and so he makes her believe, you know what is not real, and that's essentially there you see the definition: manipulate someone by psychological means into doubting their own sanity. Okay, so that's essentially what gaslighting is. He's saying, I'm gaslighting, I'm leading you to believe what is not real, and somehow I'm misleading you, fooling you, or whatever. Okay, so let's look at a little bit of that. First of all, here's another person who said the following. Says Galileo was ridiculed. Okay, and yeah, he proposed that there were 4 other moons that no one had seen before. He saw them through his telescope, and the bishops, the cardinals of Rome, said, "Well, they're not in the Bible, in the book, in the good book. So we don't believe you, And so they ridicule him. And all I want to tell you is, uh, in so-called science, physics, even in, you could say, in philosophy, a lot of that gets mixed up with physics. For the last 3,000 years, people have been laughing at each other. Half the world laughs at the other half. You have the Hindus, they laugh at the Buddhists laugh at the Muslims at the Christians at all of them. And they all laugh back. It's very common to ridicule and laugh at those people who don't have opinions or theories like yours. And so this is very common, and nothing has changed in the last 3,000 years. Here, let me give you some examples. Okay, let's go through that so that we make sure we cover all these bases. Here's the first one. Okay, this is Mr. John Baez, and he created the crackpot index at UC Riverside. It's been there for the last 25 years. Says these are just 3 of the items taken out of that crackpot index. Some of you are familiar with it. First one there, number 11, says 10 points for each claim that quantum mechanics is fundamentally misguided. Then the next one says 10 points for arguing that while the current well-established theory predicts phenomena correctly, it doesn't explain why they occur or fails to provide a mechanism.
That's on there?
Yeah, you would think that that is supposed to be what physics is
The whole
about.
point. Yeah.
And this gentleman, he's there at the UC Riverside. He's a professor there, and he says that apparently in his mind, that's or what he learned in school, that's not part of the scientific method. Okay, are we okay there?
Yeah, yeah, yeah. I was
There,
just
okay.
highlighting everything.
We're getting errors from YouTube as usual. I don't know why. Anyways, and then the last one there, 10 points for each claim that special or general relativity are fundamentally misguided. Again, what I want you to notice here is that this is from UCI, University of California at Riverside, okay? And, what I want you to understand is you're paying taxes, and Riverside is partly maintained by government funds. So you're paying for these people to have on their website officially for the last 25 years these uh, this crackpot index, and they'll use it against you, and they'll ridicule you, and here you're paying for to get ridiculed. Maybe you don't agree with general relativity, with space time. Maybe you don't agree with quantum mechanics, and here they're saying if you don't agree, well, you're a poo poo. That's essentially it. So you're paying for that. So think about that. Yeah, they do ridicule you in science.
So if a little
It's
kid comes up to that guy and asks, "How do two magnets attract each other?" He says, "You're a crackpot, kid. You're asking the wrong questions."
yeah, exactly.
That
And
doesn't
we'll
make
get to
sense.
that. In fact, that's the subject matter of the science critic. Here's another one. Okay, so that you can collect them. Okay, here's number two. Says John Rene, and he talks about the laws of credibility. Now it's important to know that John Rene is a big shot up there. He created the Stack Exchange, and you can look it up. That's a primary scientific or physics, mathematical physics, right? Site that people check regularly. And he's also in charge of some magazines. He was editor in several magazines, so he's a big shot up there. He's got censorship power. And this is what he says, okay? He says scientists don't always know best about matters of science, but they're more likely to be right than the critics who make that argument. Uh-huh. So if you're a critic and you criticize officialdom, mainstream, well, then you're not going to be right. Okay, they're going to be right. And he's got these two corollaries to the law of credibility. And the first one says the first job of any scientific fraud is to persuade the public that science is itself unscientific. Aha. It turns out that they have all these irrational explanations from quantum mechanics, general relativity, and string theory. They tell you in your face, the mainstreamers, they tell you they themselves do not understand them. But here they say that if you criticize and say that's unscientific because it doesn't make any sense, then they say that you're a fraud. And then the second corollary to the law of credibility is any iconoclast with a scientifically unorthodox view, okay, you might be a dissident, right? Who reminds you that Galileo was persecuted too, ain't Galileo. Okay, so there are no more Galileos. Okay, that's what he's saying. What's interesting that he talks about the law of credibility and the corollaries of credibility. And credibility, I think it's got to do with what you believe in. Sounds like religion to me. It doesn't sound like anything related to science.
Sounds like authority.
Yeah, and tradition and democracy. You know how many people voted for your theory. So yeah, none of that has anything to do with science. But this is what Rennie was brainwashed to believe in high school and college. Okay, but this is how they trash you. They insult you. They ridicule you. They're allowed to do it. But here, this fellow says, Bill, you're a bully. Look how you're treating all your followers or the non-follow, the visitors and so on. Okay.
I think you just built up too much resentment for all the times you were called a crackpot.
Well, no, I'm just playing the game the way everybody else plays it. So please don't pick on me. If you're going to do something, go to Riverside and ask them to take the crackpot index out of there because you're paying taxes. Those taxes are used to support the university, and they're using that to trash you because you don't believe in quantum mechanics or general relativity. That's where you should start, not beat up on me, a little old me. I'm a nobody, in comparison. Okay, and here's a final example. Here's John Horgan. He's a newsman. He also teaches at one of the universities out there, but he's a reporter primarily. He writes, I think, for the New York Times and other prominent magazines. He says science and common sense should be compatible. He argues that modern physics, mathematical physics, somehow is unintuitive. It doesn't make sense. And here we have a so-called physicist, mathematical physicist, okay, from Stanford University. And he says the following, he answers as follows. He says, whose common sense? John Horgan's, admittedly a non-scientist, I presume. Instead of dyspeptically railing against what he plainly does not understand, Horgan would do better to take a few courses in algebra, calculus, etc., etc. Modern science is difficult and often counterintuitive. Where intuition and common sense failed, they had to create new forms of intuition, mainly through the use of abstract mathematics. When common sense fails, uncommon sense must be created. Okay? That was his answer. So, yeah, all these people trash, ridicule, and belittle anyone who comes up against them. They have the power because they have all these think tanks. Every university is filled with them. They receive millions, I would say even $1 billion if you look at all the universities on the planet. They receive money from governments, from private individuals who donate money to them. You have all these centers, the Princeton Center there, you have MIT, Caltech. They're all over the planet, in Russia, in China, everywhere, and they all believe in the same thing. They're at every university on the planet. And they will trash you. They will ridicule you if you dare raise a finger against general relativity, quantum mechanics, or string theory, which they admittedly, they admit that they do not understand, that they cannot explain.
I mean, it is kind of suspicious that they would ridicule people instead of. I mean, even you take flat earthers seriously enough to debate them.
Yeah, but they don't.
They don't.
They don't even. They will not even bother with electric universe, flat Earth, and so on. I mean, they will not analyze what these people are saying.
Is dehumanizing in a way. You at least take other people's criticisms into consideration. Like, okay, maybe there's something to this, or maybe you think it's dumb, but you investigate it and challenge it. You don't just throw it away.
Right. I answer the questions as best as I can. So if a flat earther comes over, I might trash him, but I will answer. but I will answer him if it's an important. If it's an important issue, I'll raise it. I'll bring it up here. I'll put it under flat Earth. I'll ridicule the guy, but I will answer. Well, the other people, they do not even. They don't even bother answering. They don't even take them seriously.
Okay, but they have better things to do, like indoctrinate more people.
Yeah, I guess they do. They
don't have the time.
But my point is, ridicule and bashing has been around for 3,000 years.
It's part of the game.
If you do not have the stomach for it, I strongly suggest that you do not abandon your job at the bus stop, cleaning latrines.
I mean, you shouldn't do that if you had stomach for it anyway.
I mean, if you don't have the stomach for it, you're in the wrong field. This is a trashing, ridiculing field. And if
as
you don't
long
know
as we
that,
get to the point. Because if there's no point and you're just trashing, then you're wasting your time.
Well, again, after 20 years that I've been doing this, none of those, I've got a very thick skin, so none of that hurts me anymore. But it shouldn't hurt you. If it does hurt you, you have a problem. You got to see your shrink, okay? You're in the wrong field. So here I'll give you how we treat people here, okay? Here it is. This is the motto of the Bill Gates School of Physics. We teach with a baseball bat. Okay? So if you say something which is dumb,
rolling pin works too, I guess.
Yeah, well, the baseball bat's too long, so I use my dough roller. Okay, so just be aware. We're not going to be kind to you if you bring nonsense over here. Okay, so just make sure you feel at home. If I say something that offends you, just take it in a different way. That's the way I look at it. We do not insult anyone. We treat everyone with the respect that they deserve. Okay? Okay, moving on here, folks. We have fellow says, he says, physics and measurement go together like bread and butter. Measuring objects puts them in their place accurately.
We got a stamp collector.
Yeah. He says measurement is science. So
Yeah.
if you measure a table like that little fellow there is doing, he says you're a scientist. Okay, so he says that measurement is science. And yeah, that's when we bring the dough roller.
What did he say? Get the fucking.
We educate them the right way. We learn them. Okay, we learn them. Okay, so here we have a little bit of some answers. What some of the things that physics does not do. These are not activities of physics. Okay, so in case you use any of these activities, you do some of these activities, you think these belong to physics, here we correct you. Okay, we learn you properly. Okay. Okay, so here he is. We have observe. We do not observe. We do not gawk. Okay, which is what all these people are doing on the right. Okay, we do not do experiments. We don't do experiments in science. Yeah, you heard it right. Let me repeat it because some people say, well, he must have misspoken. No, we do not do experiments in science. Anyone can do an experiment, not learn anything from it, and he thinks he's a scientist. That's not the way it works.
I'd say it differently. Hold on. I'd say these are part of science, but it's not the crucial part of science.
Okay,
they're like the preamble to science.
Yeah, we're saying well, the way I like to put it is this way. This is the way I put it. There's the detective and there's the prosecutor. Okay, now they have two different jobs. Okay, the prosecutor is the person who says you're innocent until proven guilty. Okay, and he goes through the motions of explaining why he thinks you're guilty. The detective works exactly in the opposite direction. He says you're not off the hook until we can verify your alibi. Until then, you are a suspect. You are considered a suspect still. Okay, so they work exactly in opposite ways. Meaning, the detective goes out and does all his job. He looks for evidence, fingerprints, whatever he found out there, the gun, etc. Right? He gives all that to the prosecutor. He is not a scientist. He did the investigation. He did all the hard work. He is not a scientist. The scientist is the prosecutor, the guy who has to explain it at the conference. Yeah, he's got to make sense of it and present it to the jury. In this case, present it to in the conference. He says, "This is how the universe works." For example,
you're basically saying anyone can ask the question, but to answer it, because anyone can drop the pen, but to explain why it drops, that's the science part.
That's one issue. The other one is research is not science. Okay? Research is not science. You can research all you want. It doesn't mean you came up with something. It's the guy who presents it and says, let me explain it to you. That's the scientist. But to do research and not make any progress, not have learned anything, so what you did research? So what if you studied? So what if you observed? So what if you did experiments and did not learn anything? That's the detective. Okay?
I'd still say it's part of science because it's the whole process. I add that to the process, but it's not the crucial part. If you just do that, you're not doing science.
We chop it off here.
Yeah, if you want to go clean, if you want to make it as clean as possible.
Here we say only the prosecutor, the guy who presents a theory, is the scientist. That's the only guy that's a scientist. The other guy who did all the hard work, he's not a scientist. He's just a lab worker.
You're the gopher.
He's a gopher.
Hey, bellboy.
Okay, yeah.
Do the work. I'll put it together.
So I just want you to know what we say here, okay? Anyways, none of these collect data, devise equations, predict, making predictions. That's called an astrologer, okay? That's not a scientist. We don't present evidence, okay?
We assume.
Not in the case of prosecutors. You know, in the regular law, people present evidence. In science, we don't. We just explain without evidence because evidence is used to persuade, and we do not persuade in science because that has to do with religion, with convincing you, with twisting your arm, okay? We do not test theories. We don't verify or falsify theories. We never fake anything, no falsifying in science, okay? We don't prove, we don't know. Knowledge has nothing to do with science, okay? We don't believe, we explain. We don't persuade, convince, convert, or recruit. We don't invent. Technology has nothing to do with science. We don't form clubs, associations,
I don't know about that one.
groups with other people. I mean, you can if you want. Congregations, that's got to do with religion,
Well, just because
not
you
with
do
science.
it doesn't mean you are a scientist. The other way
Right,
around.
right, and that's my point. And then we do not give prizes. Okay, so none of those have anything to do with being a scientist or a physicist. And one step further now, we move one step further and we say science does not use any of these terms. Okay, we do not use the word force. We do not use the word field, energy, mass, time. None of those words.
I got a caveat without defining it rigorously.
No, even if you define it rigorously, because none of those words can be defined rigorously.
That's your assumption.
No, that's my knowledge. I know for a fact.
You got no on deck.
Okay, none of those words belong in science. Why? Because let me tell you what the origin of those words are. The reason you learned all these words, probably in high school, probably in college, okay, is because the mathematicians put them in your head. Okay, they shoved them into your nose holes and
ear holes.
Shove them into your nose holes, and what happened with that is that you memorize them, and now you move these things around. The problem here is that you treat them as physical objects. And as the subject of today will be, these are all concepts, and you cannot treat a concept as an object. That's where the problem is. Okay, so if you use any of these terms, we will use our dough roller on you. Okay, you can't make your case with any of these words. Okay, that's where it starts. Okay, and you will find a couple words there. One is ether at the bottom left there, and electricity in the top middle there. Okay, ether and electricity are not physical objects. And people say electricity moves, current moves, runs, whatever flows. You can't use that language in science. And no, this is not semantics. Okay, people say, Bill, you're doing semantics, you're doing word wizardry. We're trying to teach you how to talk in physics. Okay, and it's very hard because you learn something different in high school and college. And so you're so used to saying the current flows. That's like saying the river flows. Now, the river already is flowing because river means water that flows. So you can't say the water that flows, flows. That's what you're saying when you say the river flows. And when you say electricity flows or current flows, you're saying current is what? What is current? Current is, if you go with the official, the mainstream, it's electron. It's the motion of electrons from one atom to another. That's what it is. If that's what you believe, you might have a different version. Okay, no problem. But in general, people think of current as the flow of electron beads from one atom to another. The electron bead is the object, a little ball there. That's what you got to think of it as. And it's flowing. It's going from one atom to another. That flow is called electricity. You cannot say electricity flows or current flows. You can say the electron flows. Not that the electron flow is flowing.
Yeah, you can't say the movement is moving.
So we're trying to teach you how to talk, and people don't like to be taught how to talk because they say, I've been saying current flows for years. Yeah, because that's what they taught you in high school.
Well, I think the way you just laid it out is more convincing, or more. It's clearer for the listener than just saying don't use these words. It's better to explain. Look,
why?
What are you saying right now? Yeah. You're saying that the motion moved.
Yeah.
What does that mean?
You're saying that the electron flows.
Yeah. And the electron can flow faster, maybe, or change direction.
Yeah, but that's not what they're saying.
Yeah.
They get into that bad habit, and what you're doing is using words of mathematical physics. None of those words that you just saw belong to math. Math deals with numbers and with operations on numbers, right? That's math. And what they did, they said, well, how do we apply this? How do we make any sense of the world if we don't introduce math into that world and measure and analyze it mathematically? And that's where we have this religion known as mathematical physics came into being, and they had to create words to be able to give some physical interpretations to the equations. That's when they created the word force, the word mass, the word energy. all these irrational terms, which are not only undefined, but even if you were to define them perfectly, they wouldn't make any sense.
Their notions are nounified verbs.
Yeah, because they concretize them, or however you say that.
Like force. Force is a good one,
they-
where it's like force already implies motion, but when you say the force moved something,
Yeah.
no, the thing that moves something moves something.
Yeah,
Force
you
is
can't
just a concept that we use to explain that.
Yeah, because all you
Or
said
to
is
describe it.
is pushed it. That's all you said, or pulled it.
It gets
You
real
can't
weird.
say that. You got to say, what is the physical object that did the pushing? Then you can talk about force. And then you don't need force at all, because now you mentioned the hand and the box, and you said, my hand pushed the box.
Mhm.
We're done. We don't need the word force. But when you say a force came up against the box, now it means you
Now
drank
it's
too
getting
many
weird.
beers. Okay?
I mean, I keep telling you, I think robots and programs could do better physics than most people. Because if you have to define everything so rigorously, they would find all the kinks in the theory.
I think some of the programmers up there might understand that argument.
So.
Okay, so here's one fellow, and he uses ether, and he says there's nothing irrational about the ether. It's nothing mystical. It's a fluid. Okay, you mean like water? It's and what is water? Well, water is it's a fluid, just a bunch of atoms, right? It's a fluid. He says ether is only irrational if you believe it's made of particles. Okay, well, what is a fluid made out of? I mean, if it's
atoms, not particles. Come on.
Yeah, a fluid is made
What
of...
do you think an ether is? What are you, dumb or something?
Yeah, what do you think the ether is? Well, the ether, you got to tell me, first of all, because you're introducing ether. But there you have the ether. It's a bunch of particles, and that's what they say. Well, there's two versions. One version is that the ether is space. Space and ether are synonyms. They're identical. Mm-hmm. And another one is that ether is within space. Okay, those are the two versions that are out there. And so the question here, in that case that you see there, you see all these little dots. That's the ether. The black stuff is space. So it's ether within space. Yeah. And what is moving there could be one of two. It's either a wave moving through the ether, or it's the ether itself, which is vibrating. And we have all these versions out there of what the ether is and what a wave is and all that stuff. Okay, so you have to be very specific about what it is that you're moving. The physical object is absolutely crucial. You need to identify it.
Well, it's also the base assumption from which you explain things. So the properties of it have to be rigorously defined so that we can get all of the because when you make an assumption, especially a base one, you get a lot of resulting, I guess, like logic from it. Like, for example, yours, when you say all atoms are connected by ropes, that's an assumption. We don't know this. We're just assuming it.
Yeah.
But once you assume that, when you follow that line of logic, you get all these tangents of what that means.
Yeah, yeah.
And it's the same thing here. You have to really rigorously define that assumption, because if you just change a little bit of it, you're going to get way different.
Yeah.
It's like in a golf swing.
That's one issue. But the other issue is that you have to identify the object, and there's only one way to identify the object, is put it in front of our eyes so we know what you're referring to when you say ether. So you have to point to it and say, look, this is the ether. If you're going to treat it as a physical object, if you're going to vibrate it, okay? And there's a difference between vibrating all the ether in the universe, as one block, as a single thing, okay? And vibrating a teeny region of the ether and saying, well, a wave is the vibration of the ether. No, if you're going to vibrate the ether, it's the whole thing. If you're going to use a little portion of the ether, you better call it something else. That's not the ether. The palm is not the same thing as the hand. Palm is a region of the hand. If you're going to use a region of the ether, and you can't say the ether vibrates, and that's what light is, the vibration of the ether. No, but if you're vibrating the ether, you're vibrating the entire universe as a single thing. That's the ether.
If the ether is the collection of all these regions, you could say, then vibrating the ether would mean vibrating the collection of all the regions.
Yeah, you gotta separate the ether
it's just
from
logic. You just apply rigorous logic to everyone's words, and then things fall apart real quick.
A lot of these people are not logical. That's the problem.
Well, I don't think they get to the bottom of what they're saying. What they themselves are saying.
And here you have a definition of the ether. Two definitions. One is from the dictionary: upper regions of space. The Greeks essentially called it ether, which I think means air. It was the God's air. Okay, the air that was outside the earth that they couldn't touch or see. Okay, that was the ether. It's a special type of air. And what is the air? Made out of particles. Okay, made out of units.
I
Okay,
breathe
whatever.
special air, not your peasant air. Mount Olympus air.
And then the other one at the bottom, postulated medium for the propagation of light. And again, either the ether is what is vibrating or the light is passing through the ether. It's the medium through which this whatever light is passes through. So
light is either being carried by the
Yeah.
ether or it is the ether's perturbation.
So you got to identify which of the two it is. Is light the vibration of the ether, which is what the 19th centuries believed, or is light something else separate from the ether that goes through the ether as if like a fish through the water?
But
through
I
the
guess,
ocean?
but along the same lines, it kind of also applies to the black hole and these kind of things where there's so many versions of it, you can't just criticize because like, that's not the one I was talking about. So they give you the runaround. Yeah, not that one, not that one. You're thinking of someone else's black hole, not my ether. And shit
So
like
when in doubt, what we do is we go to the sources. And the original source were the
but there's many sources.
No, yeah, that's what I'm saying. The original source, you could say, is the Greeks, which also inherited that probably from the East somewhere. I don't think the Greeks were the originators, but they used that same concept, the notion of the ether, and it was resuscitated more or less by Descartes. Okay, Rene Descartes, and this is what he had to say about the ether.
What's with the ugly cartoon?
Yeah, you got space is a plenum. Okay. And he says, and what is a plenum? Well, it's a space or all space, every part of which is full of matter. Okay, so again, we're talking about a bunch of particles. That was his notion. He says, what fills space is the ether. Okay, and then you see that other paragraph there, and all this it comes from Edmund Whittaker, who wrote a history of the theories of the ether. And this is a statement taken from Rene. Okay, it says the vehicle of light is composed of a closely packed assemblage of what? Globules, spherical particles whose size is very small compared to the bodies we see on Earth. So what are we talking about? Little particles. That's what the ether is. It's comprised of all these little particles. The globules are pressed in contact with each other and move outwards. It is the transmission of this pressure which constitutes light. So in the case of Mr. Descartes, he thought that light was itself the vibration of the ether, and that's what all the 19th centuries also who came later, right, also believed. They always thought that light itself was the vibration of the ether. But again, it's the wrong notion, because if the ether is what fills all of space, you cannot say that vibration of the ether is light, because you got to look at the whole object. The object is the whole shebang.
Well,
You
along
can't
that line,
pull a little bit out of it and say it's a vibration of the ether. No, it's a vibration of a bunch of particles that constitute the ether. Then you can say that, but not that the ether is vibrating.
You kind of have the similar situation where when you're explaining light with the rope hypothesis, you just take a chunk of the whole.
And I call that a rope.
Call it a rope, yeah. But
I don't call it a thread.
You, in the end, I guess, are taking a chunk of the entire.
I am. Absolutely, I am. But when you say rope, I'm referring only what's between two atoms. I'm saying this is light. So, but you can't do that with the ether. You can't say, well, the ether is everything, and it's also the little thing that I'm going to vibrate.
That makes
you can't do that.
It just confuses people.
Yeah, and that's where the problem is with all these people. Well, just in case we have some reinforcement here, we have these people. Robert Boyle. The ether consists of subtle particles. Huygens, he said, ether is constituted of particles. Newton, ether is made up of numerous small particles. And Johann Bernoulli, ether is comprised of excessively small whirlpools. All these people thought of the ether as a bunch of particles. That's the notion they had of the ether. Okay, and again, some of them said it fills space. Most of them had that notion. Others equate it with space and say space and ether are the same thing. It's like the backdrop to every little thing that we have here on Earth or in the universe. But the problem there is that space is considered to be infinite, meaning the ether is infinite, and there's a difference between an object, a thing like an ocean, right, and something which is infinite, which is not a something at all. If it's infinite, it's the opposite of an object. Object is that which is finite, okay? And infinite means that it's not an object, still growing, or you haven't conceptualized it properly. You can't see the edges of it, the surface, whatever. It's not an object. So if you're going to treat the ether as an object, I want you to draw it. Okay, you got to put a picture in front of it.
But then you also have to explain what encapsulates it.
Yeah, and we'll get to that in a second here. In fact, here it is, okay? See, all these objects are finite, okay? And here you have the solid, okay? You have a liquid and you have a gas, and they're all finite. All those are objects. Those are things. In fact, if they're made of atoms, they had better be things, because an atom is a thing, so anything made of atoms had also better be a thing, okay? And so solids, liquids, and gases are all things, okay? Okay, but here we have what an object is. In fact, what you just said here, okay? Here's an object, okay? And we'll call that air, just a blob of air. And we've frozen the picture. We took a snapshot of air, and unfortunately it was colorful, so we could see what it looks like. That's what that blob is in one frame of the movie, okay? Now, as you can see, I've got some black stuff around it, but that black stuff, I put a frame around it, but that frame is artificial. The black stuff is not infinite, it's not finite, because it's not an object, it's a concept. Black stuff is nothing. That's what it's known as. And nothing is that which doesn't have shape. But if you want to argue that space is ether, ether is space, and that space is a physical object, or that ether is a physical object, okay, then you got to do the following, which is what he just mentioned, and that's that. You got to tell me what the white stuff is that encapsulates the ether.
Assuming it has shape.
Or shape, yeah. But it's
got to. The ether is finite.
Yeah, if it's finite,
shape, yeah, and that means there's something that's around it.
Right, something has to give it contrast. So you got to identify the white stuff. Okay, so that's your task. If you cannot if you cannot make a picture of the ether, and you cannot draw something around it and tell me what that white stuff is, you cannot even start your presentation. We're not done with your proposal. With your
the proposal is usually where all the time goes.
You gotta spend 2,000 years on the assumptions and 5 seconds for your dumb theory. We don't care about that. Right? Okay, so here we have the other, those were the etherists. Then you have the electric universers. Okay, here these people say electricity is flowing potential for work. Flowing potential. We have a concept that is flowing. Now that is scary, okay? And again, electricity is a river. It's electrons that are flowing. So you can't say electricity flows or current flows. That's irrational.
Electrons flow.
Okay? And then he says plasma, the first state of matter. Well, I don't know. I thought the first state, what was it, South Carolina or Virginia? Well, those was the first state. I can't remember now. Yeah, there is no such thing as a first state of matter. Okay, and if plasma is a state of any kind, which means what something does, then for sure plasma is not a thing, because a verb is not a noun. Okay, so I hope you understood that. Okay, he says, what the Webb telescope reveals must even amaze and awe Bill's physics cynicism. Yeah, we don't care what the Webb telescope, James Webb telescope, reveals, because we don't care about evidence. We try to make sense of how this universe works, and for that we don't need evidence at all. Evidence is what you use to convince, not to explain. We here explain. Okay? We try to explain in a rational manner. Rational means that we're not going to move concepts around, such as, what was it, potential? The flow of potential. Whoa, the potential is flowing. That's dangerous.
The flow of potential jumping.
And here you have another movement of concepts. This is Mr. Wal Thornhill, and he's the head honcho at the Electric Universe. And all these statements here come from his a video he made recently, Twisted Pairs and Braids Everywhere. Okay, but the problem is the twisted pairs and braids, these filaments, are not things. He calls them filaments, but they are electricity. They're flowing flows. That's what they are. The flow of flows. Okay, and there you see filaments are like those in a plasma ball. You've seen all those little things that come out of a plasma ball, those lights. He's saying those are the filaments. Okay, so what are they? They're currents, rotating Birkeland currents. Gravity alone cannot produce each twisting and turning filament structures. Okay, so the issue is he's calling them filaments, but what is a filament is the flow of electricity. Okay, the flow of flows again, flow of electrons that are flowing. Okay, that's what he's saying. So he draws them as two, as a pair of twined threads, a rope. But that's very, very misleading because he's not talking about threads. He's not talking about wires. He's not talking about, strings or anything like that. Wires, any of those. What he's talking about, each one of those strands that you see there, that's electricity flowing, meaning electrons which are flowing. Okay, and he has these electron flows twine around each other. Okay, so he doesn't even know what he's doing. He doesn't even know what he's saying. So he said rotating electric currents that flow. What do you mean a current flows? And it flows as a filament, helically twisted pairs and braids. No, these are not braids. Please do not confuse a braid with a flow of electrons. Okay, if that's what he means by electricity
Is
or
it
current.
because he's talking about the trajectory?
He's talking about the trajectory of a bunch of electrons. That
he's
have
twining their trajectories.
Yeah, and he calls them braids.
But that's the thing. He's again nounifying the verb.
Exactly. He's turning verbs into nouns.
It's like you talk about the how was it, Super Mouse, or what was that one show called, where the lamb would stand on the.
Oh yeah, it's Mighty Mouse.
Mighty Mouse.
And Mighty Mouse has this contrail behind, and the lamb walks along the contrail. He essentially turned the contrails into something
into
a little more solid, And this is what this fellow is doing, And he says filaments are electric currents. No, if filaments are electric currents, then he's talking about nonsense. They're not braids. He should not call them filaments or braids, which refer to physical objects, whereas his so-called filament, these currents, they are not physical objects. Current is a river, okay? And unless you understand the language, you're talking nonsense. And that's what all these people do. And when you point that out to them and say, well, you're doing semantics, Bill, I didn't come here to learn grammar. I came here to do physics. Well, to put it nicely, physics is 150% semantics. Okay? If you do not do semantics, we're not going to understand what you're saying, especially if you say that your filament is curving around and turning into a braid when you're talking about the flow of electrons. Okay? And again, if you're going to have a flow of electrons like the electric universe says, you better have atoms that, the electrons move from one atom to another. What these people think is that they can do without the atom altogether, and you have only the electron beads moving across the universe from one galaxy to another. No such monster in science or in physics. Current is not the flow of just electrons without any atoms underneath it. Okay? Current, is, according to the official version, because this is not even current, but conceding it, that the official version is correct. Current is an electron that moves from one atom to the next. There's no such monster as no atoms, and the electrons, just a bunch of electrons flowing across the universe. That is total nonsense. That's what the electric universe believes in. That's what they're proposing, that electrons alone form these filaments, and these filaments, which are just water flowing, electron flow, and they twist around. They form these twisted filaments called braids or whatever. That's total bunk. It's nonsense. All of it, trash, completely in the trash can.
But to be honest, when you have that much, I think,
yeah,
that much, you're gonna always have semantical issues because words just kind of complicate things.
Yeah, but you got to get your language right from the start.
But what I'm saying is, it's hard to evade that because in the end, it's just better just to watch the movie of how the universe works.
Yeah, also, hold it. But see, if we watch his movie, right, of the two braids, right, you would think that you're looking at something, and they're not talking about something. But there is a something, which is the electron, tiny electron. But they pull a million of these or gazillions of them. They turn them into a tube. And they say, well, yeah, it's a filament. Then we have these twisted filaments. They turn into a braid. And and you lost track of
And
what
then
they're talking
they
about.
hit you with the trajectory of the freaking electron. They throw the baseball bat, and then they take the trajectory where it traveled, and then hit you with that stick.
Okay, so just in case, yeah, here we have a fellow. He says, no one in the electric universe community has ever claimed that gravity is equivalent to electricity, because I mentioned that the other day. What they say is that gravity is an electric phenomenon. Aha, okay. If I say my car is electric, that doesn't mean I'm saying my car is equivalent to electricity. Okay, you see his argument. One is an adjective and the other is a noun. Learn the difference. Okay, let's see if I need to learn the difference or maybe he needs to learn something here. Okay, let's find out.
I don't think anyone's learning.
Okay, car is an irrational analogy for the comparison of electricity and gravity.
Okay.
Both are processes, phenomena. Car is electric is not equal to gravity is electricity. Okay, so yeah, car is a noun and electric is an adjective, but here he's comparing apples and oranges when he uses that analogy,
Yep.
right? Here we're talking about gravity and electricity, both of which are verbs. They're not nouns for the purposes of physics. Both gravity and electricity are processes, phenomena, meaning verbs, okay? So let's get it right, okay? And yeah, this fellow apparently needs to learn some language. Again, the language of physics. And here, let's show them. This is what two sources, which I pointed out last time. One comes from the Electric Universe book. This is their handbook, A Beginner's View of Our Electric Universe by Tom Findlay. And he says the following, again, gravity is a manifestation of the electromagnetic force. Gravity itself is fundamentally what? Electrical and just another what? Aspect of the electromagnetic force. The four fundamental forces, the weak, strong forces, electromagnetism, and what? Gravity, will all eventually be seen as having their common root in the electromagnetic force. According to the electric universe, there is no such thing as gravity at all, anywhere in the universe. It's all electric, all electricity. And then we have at the bottom Mr. Walt Thornhill, the head honcho. I mean, if he doesn't know, I don't know who does. Says the force of gravity is a manifestation of the electric force. Okay? And gravity is an electric dipole force between subatomic particles. There is no such thing as gravity according to the electric universe.
I mean, that's fine if they can say it. I mean,
No,
that
fine.
could be the
But
case.
this guy's denying it. This guy said, Bill, you're wrong because we didn't say that gravity is electricity. Yes, that's what they say. Exactly. You don't know your own religion. You go every Sunday to Sunday school, electric Sunday school, and you listen to the pastor talking.
Instead of the plus for the cross, they have a negative.
And he doesn't even understand his own religion. Yeah, according to the electric universe, there is no such thing as gravity. Gravity is the wrong word. It's an inexistent word, should be taken out of the dictionary. Everything is electricity. And that contradicts what they say, which is that gravity is orders of magnitude weaker than electricity. So they have a contradiction. On the one hand, they say electricity is not gravity because gravity is much weaker than electricity. And then on the other say, look, ultimately everything's electricity and there's no such thing as gravity. So they have these contradictions. That's why the electric universe is absolute nonsense. Poppycock. Okay? And I say it here. Okay? Again, for those who don't understand,
I think the roller's going to break before
too many heads
the
to
year,
bust.
yeah.
Okay, so here we have all these Flatlanders, as I call them, okay, and because of that, they have no idea what gravity is because
They also don't use gravity. They use the acceleration of Earth going up, I thought.
Well, because the problem here is that they use concepts to define or to explain gravity. So when you use other concepts such as ether and electricity to explain gravity, all you're saying is that love is a different way of doing intelligence. And so far you've said nothing. You said, or like Einstein said, mass is another form of energy. Well, so far he said nothing because neither energy nor mass belong to physics, and both are concepts. None of them have been defined.
They've
been
defined with each other, so it becomes
tautology and circular reasoning. So here you have it. Okay, so these are the great bean brains of Flatland. Okay, one Flatlander says gravity is warp time. Another one says gravity is energy. Another one says it's density. Another one electricity. Another one says it's negative momentum transfer. This is what they came up with, all this nonsense. Why? Because they're using concepts. They're using concept, time, energy, electricity. All those are concepts. You cannot say the concept gravity is the concept electricity or the concept momentum or whatever.
Yeah, where are the objects?
Yeah, we need to find the objects, and we don't see any objects here. Okay?
So far, nothing's doing anything.
Yeah, all you have is one concept defining another concept. Or you're explaining, supposedly explaining, quotations on that, explaining gravity by using another concept. And we haven't learned anything. As long as you say that love is just another form of intelligence or of data collection, you haven't said anything.
Well, maybe, again, a lot of these semantical problems arise from our preconceived notions of all these words. If you just replace those words with X,
yeah,
then
exactly.
Then it gets then you won't, at least, I mean, you'll be confused, but for a different reason. But then if you defined X, you'd get closer than saying time, because time, we all have different ideas of what time is, and it's hard to define. And
they never defined it.
I know, but it's just, you get into this whole mess. If you just said X moves people, and that's why gravity. That's what gravity is mediated by X. Then you still have to explain what X is. And you have to draw
that's
it.
One issue. The other important issue is that you learned all these concepts, mathematical concepts, in high school.
And you think you know what they mean, but you don't.
And in fact, a lot of people drop out of physics and say, I didn't understand anything of all those force and work and energy. I didn't understand any of that. So they say, I'm out of here. And those people who say, okay, I think I understand it. And all they give you is an equation. Look, force is equal to mass times acceleration. Work is equal to that. Energy is equal to that. And so all they're giving you is a bunch of equations, calling them names, and then using those words, which are concepts, to explain to give you a physical interpretation. That's where the problem. That's when they cross the line into physics. That's where it's illegal. That's where it's irrational.
Red card.
Yeah, stop. You get a ticket. Okay, so they don't know. None of these people know what gravity is. And here you have what we were doing these other days. Okay, we start out with this situation where
this is your new obsession, isn't it?
Well, yeah, I'm just gonna, because nobody's answered that. But essentially, we have a tree, okay, and we built the van over the tree, okay. And what happens?
To do an experiment, we built a car on a tree.
Yeah. So we built the car on a tree, or let's say we parked the car there for a long time, and a tree grew under it.
Just to be clear, there's no floor on the car?
Yeah, there's no floor, and the tree is not touching any part of the van. It's just underneath it, okay, not touching any part of the van. It's exactly, in that sense, like that molecule, that atom there, whatever you want to call it, a particle, okay? But what happened? That air molecule, okay, it's just floating around. Okay, so what happens? When we accelerate the van, okay, this is what you should expect, okay? The tree stays behind, but it turns out that the particle also stays behind, okay? So we ask you, why did the tree stay behind? And you say, well, the tree is stuck to the ground. Well, why did the particle stay behind if it's not stuck to the ground? Okay, you see where the problem is? You have to answer why the particle stayed behind. And what do people answer? They say, well, a force, force being a physical object, force did not push the particle. That's what they say. It never occurred to them that maybe a force, whatever that force is, kept it there. So they only talk about moving it. But see, they didn't say that for the tree. They said, well, the tree didn't move, not because a force didn't push it until the van touched it, right? The back of the van, but because it stuck to the ground. Okay, that's how they say. Okay, so we have to create a different situation for these people to understand. Now we have the tree just lying underneath there. It's not stuck to the ground. Okay, so neither the tree nor the particle are stuck to the ground. What happens when the van accelerates? Well, now both of them again stay behind. In the case of the tree, now you say what? Again, the force did not come and push the tree. Is that what you're going to say? How about a force keeping it there before something pushed it?
Did you ever? Gravity?
Yeah, exactly. We're talking about gravity.
Old gravity.
Good old gravity. And
electricity.
And so here we have the situation where some people say, well, we have all these molecules that are keeping the particle in place. And so, but if that were the case, other air molecules, then the band would move all particles at the same time, including the one that the target molecule, right? The target atom or whatever, the target particle. Okay, so you can't say that the reason that particle stayed behind is because it was kept in place by all these other molecules, because if that were the case, they would all move together. Instead, what we see is this situation, okay, where, give it a second here, where some particles are being pushed first. Sorry, did I get the right one? Oh, I guess that's the one I meant. I got the wrong one.
There it is.
Oh, okay. That's the one I wanted to see. Okay, so here you see the particles are being pushed one at a time. You can see the red particle does not move until the other particles touch it, you know? And so the issue is what keeps the red particle in place? And you might say the other particles, see, but the other particles are touching all the other particles. So you can't say that it's the other particles that keep it in place. Something else is keeping that red particle in place aside from all the molecules that are next to it. That's what you got to say.
It's a combination of gravity pulling it against the sea of marbles under.
Correct. So we do have a sea of marbles underneath it, but that's not the only force, right, acting upon it. We have the force of gravity.
Let's not use the word force.
Yeah, and so we have to identify what the force of gravity is. Okay, and so here we have it. Okay, and this is just a picture of that. We need to know why the molecule, the red molecule there, is staying in place until the other molecules that are pushed by the band come in contact with it. That means that the other molecules are not the only ones keeping it in place, because here I artificially drew some spaces between them when there are no spaces. Okay, so that's the situation. Okay, so what do we propose? Well, we say gravity is something else, and it looks more or less like this. The particle stays in place aside because of all the other molecules, because every atom on Earth is bound to that molecule, and that molecule is bound to every atom on Earth. Okay, I didn't draw all the connections, okay, but that molecule is staying in place, more or less in place. It does move a little bit, right, in their region, but not as fast as when the band hits it, right? But you can see it's staying more or less in place. Why? Because it's connected to every atom on Earth. And here we have someone who vouches for that, and that's Mr. Richard Muller.
Did you give this guy any money, Bosh?
Says,
he pay you?
Every atom on Earth is pulling on every atom of you. You're also pulling on it. Okay, and now the question is, how do you explain that statement there, those two statements there? How do you explain those two statements with ether, with electricity, with space-time? I'll let you have your pick. I don't care. Okay, you pick whatever you want. Please explain how every atom on Earth is pulling on every atom of you, and how you're also pulling on it with anything that comes to your mind. I don't care. Okay, just explain it. Explain those two statements. If you cannot explain those two statements, you have no theory that's worth even listening to. Okay, so that's the situation. People say, oh, I know everything about gravity. It's the ether, it's the electricity. Just tell me how, or space-time or whatever. Just tell me how it is that every atom on Earth is pulling on that atom, on every atom in your body, and how every atom of your body is pulling on every atom on Earth. Gravity goes right through things. That's what Mr. Mulder said.
Does that mean the gravity particles that every atom is shooting to every atom? Would that be the thing?
Well, if you're shooting,
every atom on Earth would have to be shooting these the negative momentum particles.
Oh, negative momentum.
The negative momentum particles, but to every other atom. That means at every moment it's shooting just a line of negative.
Through the others.
Through the others, too. Real good aim.
Yeah. If you're going to do this with gravitons, well, good luck. You got a big mess. God would go crazy with his computer trying to throw all these little balls through other balls to hit this and bring it back. I mean, through the other ball. Oh, my God. Yeah. Okay. So one fellow says, yeah, we do it with a rope model. Okay. The rope, those are the connections that we propose. One fellow says, says your ropes are a concept.
Oh.
Ropes are a concept. My God, some people, it looks like, I don't think this fellow went through kindergarten. Did he ever play with blocks?
Well, I would say the reason why someone would say something like this is because we can't see it, so we have to conceptualize its shape.
We're getting
But that
there.
doesn't make it a concept. That just makes it really small.
We're getting there. We're getting there. Is a tree a concept? Is a rock a concept?
No, I
is a
would
table
ask this person, is an atom a concept?
Yeah, again.
Because it's really small, we can't see it, but we can all conceptualize
Yeah,
what it is.
they go nuts. They go crazy. They go wacko when they can't see or touch something that they say, oh, that's a concept. Mm-hmm. It has nothing to do with see, touch, intangibility, invisibility, none of that. Has nothing to do with that, but that's been 3,000 years of history in so-called science, mathematical physics. That's what people thought an object is, that which you can see or touch. So if they can't see or touch it, they say, it's not a thing, it's not an object, it's a concept. Not true. Likewise, they say for all these geometric figures, like squares, they say that's a concept. You're staring at an object, it's got shape, but you're saying it's a concept. Again, the notion of concept that they have in ordinary speech, in irrational language, anything you can imagine, who knows what a concept is over there, right? In physics, a concept has to be defined. It's got to be defined because you got to separate it from objects. Okay, and that's where we're headed to. Okay, so here it is. Here's one fellow who made a difference between all these, and separated them. So the ones on your left are objects. The ones on your right are concepts. Okay, and those are mathematical concepts specifically. Okay, most of them, I think all of them. And you can't use concepts as objects, not in physics. And what do we say? We say there are only two categories of words in the dictionary. Every word in the dictionary can be placed under either object or concept.
Well, I guess there's also filler words like of and and.
Yeah, those are concepts as well.
Oh, yeah?
And we're going to get to that as well. Yeah, we're going to look at some of those, okay?
I thought those were just like...
No. Prepositions, pronouns, all those are concepts. Okay? Object has to have shape. Concept, that which doesn't. That's not the definition. That's a rule of thumb to detect the word real quickly, like, does it have shape? Does energy have shape? Does mass have shape? Does time have shape? If it doesn't, immediately you put in the concept bin. Okay, that's the way it works. If it has shape, a table, a rock, a rope, which this guy says is a concept, he thinks that a rope is a concept. No, rope is an object, always. Here and in the land of the Klingons. Okay, always an object. Okay, and so here, see if I can get it in here. Here you have a couple notions. Here you have these, the object, the ones in red, and then what they do is known as a concept. Okay, so you cannot confuse this. Air is the object, is the thing. Okay, and air does have shape. For those of you who say, well, what is the shape of air? No, that's not the question. The question is, does air have shape? And yeah, air does have shape. You put it in a balloon, it's got balloon shape. You put it around the earth, it's got shell shape, and so on. For those of you who believe in the spherical earth.
Well, one of the questions actually about this,
Yeah, okay.
They drew a tornado and said that it's a process which has shape, but this is exactly what you're talking about.
Yeah, tornado is moving air, so it's not a thing. Wind, there you have it, hurricane, tornado, those are not physical objects. Those are things in motion, okay? Like plasma. Plasma is a thing in motion.
It's weird that it's like flame and tornado aren't actual objects, really. I mean, but if you put it that way, aren't we also processes? Because we're
like
human beings. Like if you take a human being,
no, because
they are not the collection of their atoms. It's getting real deep philosophical. But
no.
You replace all your atoms, all your molecules every 7 years. They say approximately. Because your body replenishes itself with other things.
You're getting ahead of yourself. Someone also got into
that.
We're
basically
saying that
like
you need
tornadoes.
motion.
But
No.
We're basically like tornadoes.
This is no. Let me show you the difference. I take a snapshot of you. You're running, right? You're jogging, and I take a snapshot of you. That's an object because I can put you in a single, this is you, right? A
I got
man.
one for
We'll
you.
call it a man. Okay.
Okay.
Well, that's what you can call it X if you want. We'll call it a man. Okay.
Jimmy.
Yeah. Okay. No, because Jimmy is different than Johnny, but that's a concept. Jimmy is a
Okay,
concept.
okay.
But man, meaning man could be a woman. But my point is human. You can say that's an object. I take a picture of a tornado. I get air. I don't get tornado. Okay, tornado is in motion. I need to see a movie
But you
to
can take a
understand.
picture of a flame.
I can take a picture of flame. I don't have flame. Well, you could say you
That's
have.
what I'm saying. You're in the same bucket because you could. What I'm saying is it depends on at what level of analysis you're doing it, because you could either be, because I essentially,
Depends on what you mean by flame. Okay, flame is a tricky word, and I did have analyzed it. In fact, I treat flame as an object only because, again, I can take a picture of it and I can point to the Klingon and say flame. So as far as the Klingon is concerned, all he sees is something yellow, reddish there, bright, right? And he says a flame. Okay, that's flame. Okay, but if you're going to say that flame is part of the process of combustion, then flame is not an object. So it depends on what you mean when you point and say flame. Which one are you referring to? Fire is always a process of combustion, therefore fire is not an object.
It's definitely worth mentioning though.
Yeah, and again,
worth talking about. What exactly are you talking about? Are you talking about the table or the atoms that make the table?
Right.
Are you talking about the tornado, or are you talking about the air that makes the tornado?
And again, all these things, what we're trying to do is teach the language of physics.
But it gets tricky with tornado because it implies motion, right?
Right. And
that's
hurricane motion, tsunami motion. It's air in motion. The object is air. Okay.
That is interesting.
And air is a physical object because it does have shape. You can point. I can make a shape with air with all these atoms and call it air, and that is a physical object.
A good contrast would be the word plate. Because you got a plate, it's made of porcelain. It's made of atoms of molecules of porcelain. So you could be talking about it. You could take a snapshot of it. You don't even need the snapshot part. It's really just there's no verb that's implied in the word plate, but there is a verb implied to certain. So it gets tricky.
Yeah, but see, the word tornado already implies a verb. The word plasma involves a verb.
But essentially,
ionization.
You could break these down into three categories almost. There's objects that are static, no matter how you talk about it. There's no verbs.
Those are the only objects.
Okay, but just hear me out first. Then there's those like halfway ones, which are these like tornado, fire, where they're part atoms, but we also give they imply verbs.
Yeah.
And then there's the mathematical nouns, which are just verbs, like force.
Yeah.
So it's like force, we got flame is like a halfway point between force
those are tricky ones. Like, some people say, well, it's a cloud. An object. Yeah, a cloud is an object because I can take a snapshot and whatever atoms are there forming that cloud, that's the object at that point in time. If I can put it one frame and there's no motion involved, the word cloud does not involve any motion whatsoever, okay? Yeah, it moves from frame to frame, but within a frame, there's no motion and I still have a cloud.
Punch is a good noun.
It's not a noun. Punch is a verb.
Yeah, but that's what I mean. But it's a noun because you could take a snapshot of someone getting punched and someone say, "Oh, a punch."
Yeah, but see, no, because if the ET sees that, all he says, he's scraping he's
massaging his
cheek. You know, what I mean, you don't know punch is something else. It's motion.
Yeah. But his fist, fist in motion. It's like flame, atoms in motion.
Okay, so let's look at the definition of concept. Here it is. Concept, a word that invokes or embodies two objects. Synonyms: relation, comparison, contrast. You have to have something like that. Okay, so it requires a human. Object is to one what concept is to two. Mother Nature provided all objects. Humans invented all concepts. Okay, do we have that? That's where the word concept gets defined. Now let's look at some examples and these are not the million examples that are in the dictionary, just a few so that you can get the idea, the hang of it. Okay, here it is. Okay, informal definition, concept that which has no shape. You can use that to as a rule of thumb to determine what words in the dictionary fall under objects, which one under concepts. Here we have static concepts versus dynamic concepts. Okay, static concepts: distance, direction, perpendicular, parallel. None of these words on the left involve motion. They have no verb embedded in them. All the ones on the right, on the other hand, have motion. Okay, meter. Okay, and I'll let you figure that one why that one has motion in it. Forward. Okay, breath. Length. I'm sorry, depth, breadth, elevation. Those are all involve motion. Tandem, one thing after another, a series. Perimeter. Perimeter is something you go around. Okay. Love. It's a dynamic concept.
What is love?
Infinity means you're still walking towards nowhere, right? People, plural nouns, butter, all those, kind of like that,
Is people because it's a collection of?
Yeah, it's a collection like forest, not butter, but forest.
Well, you get into tricky territory.
Yeah, yeah, and that's why I put some of these up there so that people can go in there and look at, the word motion in ordinary speech, it's a noun, not in physics. In physics, it's a verb, okay? Living, not the same thing as exist. Some people say one of the synonyms is living. Absolutely not. Exist, there is no motion. Living, there is. Okay, so again, a lot of these, we're again trying to teach you how to talk physics.
I don't think people's a concept, though, even under your definition.
Yeah,
because
people
is like a plate.
No.
It's a collection of atoms.
Yeah, but people refers to different. See, when you look at plate, you're not saying it's a collection of atoms. No, but in the case of people, there's a collection of of humans. When you look at forest, you're looking at a collection of trees. So it's a collection. Any collection, stamp collection.
What's the difference between a forest and a plate?
That plate, you're not referring to its constituents, whereas
it's irrelevant, is what you're saying.
No, what I'm saying is when you talk about people, when you talk about forest, words such as those, which are children, and so on. What you're referring to is what is known as mereology, what something is constituted by. Okay, in the case of people, you're not referring to a shape called people. You're referring to what constitutes the word people, which is many human. In other words, people means many humans. Forest means many trees. That's
so you don't care about the shape.
So you're not looking at the shape. Okay, one fellow criticizes this. He says, self-made definitions. He doesn't like them. It's ludicrous to believe there are only concepts and objects. He doesn't say why. He just says, gave his opinion. Okay, we clean our noses with your opinion. Unless you give it a reason, we have no idea. When space, motion, collision, energies are neither. Well, so why are they none? And he says, concept and abstract idea. Well, it looks like motion, collision, energies are abstract ideas. So why wouldn't those be part of concepts according to his own proposal, which is an abstract idea? Okay, and again, these famous theorists with big ideas. Well, what is the problem? Here it is, okay? Idea. You look it up, it says any conception. I thought conception was what we wanted to define. Well, you look up conception, it says a notion, idea, concept. So they're synonym. What is a notion? Conception or idea. What's an idea? A thought, a conception, or motion.
Notion.
Or a notion. What is a thought? Thinking, idea, or notion. All those from the dictionary. What is abstract? Because he says an abstract idea, right? Abstract, thought of, apart from concrete realities, specific objects, or actual instances. Okay, and so I put that all in one nice little neat little chart, and here you see it. So you can see idea is the same thing as a conception, which is the same thing as a thought, which is the same thing as a notion. All these are synonyms. So this poor fellow, he hasn't said absolutely anything. Okay, he just copied and pasted what he found out there without analyzing any of it. So all he's got is synonyms. Okay, and so we have to, get away from synonyms. We can't use synonyms to define words.
You got to get rid of the thesaurus.
Yeah. Okay, and then regarding his other statement, that he said, these are my personal definitions, irrelevant. All definitions are personal. Someone came up with them. Do you know who the thousands of definitions in the dictionary came from? Who came up with them?
Jimmy.
Yeah, I
I
guess.
thought
You know,
Shakespeare made like
God,
half of them or something
maybe
like that.
God came up with them.
No, but they say like Shakespeare made like 10% of them words
Oh,
or
it
some
could
shit.
be.
That dude just made up
So,
words.
so all definitions are self-made. Someone made them. Okay, and you can't use copy paste definition. Just say, look, we've used this by tradition. We've always used these definitions. Everybody voted for these definitions, or say, well, this is how I was taught in college by authority. I had a very strong teacher who muscled me into believing them. None of that is an argument. You either have a rational definition, which we can put into science, or you have no definition at all. You have a definition of ordinary speech, which normally is not of any use in science. So if the definition is wrong, if it's broken, you got to fix it. Okay, that's essentially it. So you can't say, I've always used it like that. Well, I don't care.
Well,
I
you
mean,
don't
if
know
you
what
can't,
you've been saying this whole
one
time.
of them and the other one, if you cannot explain, you cannot defend your definition is worthless.
Well, it's like I keep telling you, everyone just is satisfied with notions, just approximation of definitions.
Yeah, but that's
like,
not good enough
know
because you get
what we're talking about.
You get someone like me who is a bully who beats up little kids and so on, and he comes in and he's going to beat you up with his roller.
What you mean exactly is you're gonna find the kinks in the notion. Like, well, what do you mean by this though? And not in a devil's advocate just to tear you down way, but just to it's like ironing out the words, like putting them into stone. What's the cleanest, least confusing way of phrasing these?
That's one. The other thing is that first of all, scientific definitions should be as short as possible to leave very little for the devil's advocate to chop. Okay, because if you have definitions like the word science or the scientific method or some of these other words you see out there, they have long paragraphs. Those are easy to tear down because you can tear down any piece of that.
It's not only that; it really comes down. It's kind of again back to programming, where if a definition is too long, you probably need 2 words. You gotta break it into smaller words.
Oh yeah.
If you got a definition that has too many
if ands or buts.
No, just too many what's the word? Conditions to be met.
Yeah.
Then the word is just too
that's what I'm saying.
Loaded.
Because then it's easier also to chop for the
Not
devil's
just that,
advocate.
it's just too convoluted. Like it's too hard of a word to use
computer,
correctly.
And the computer would not understand it.
Unless you used it perfectly, but even then it's better to use smaller words.
Okay.
That's the big thing. You gotta use small words. not just so people don't get confused, really.
That's one issue, but the other one is you don't want to introduce words of ordinary speech which you use or which you learned by rote, copy pasted, and bring them into science without any, indiscriminately. What you got to go in there and analyze and say, does this make sense? If it doesn't make sense, don't say, well, I found it in the dictionary.
What is it that I mean?
And this is what I got. Yeah, you can't say this is what I got to use.
Really,
the other thing you gotta understand is a lot of the words used by mathematical physicists, mathematicians, have been written by people who have no stake in the matter, by grammarians, English majors, librarians, people who have no stake in physics. They define the word for the physicist, and the physicist says, "Oh, I found it in the dictionary." Well, where did you get it?
No idea what he's even.
So
what we're using this word for.
So again, you have to ask that person: was that your personal definition? Did you self-create this definition?
They also act like the definition for these things. Like if you look up
ground in stone.
Yeah, it's ground in stone. Like this guy invented it, and that's what it means forever.
Yeah. No, it doesn't work. In fact, we redefine words every day when we find problems with it, and that's what we're doing here. We're teaching you how to speak if you're gonna do physical interpretation.
I bet you would probably have a ball being on a podcast with like a linguist or something. People who really delve into the purpose of words. I think you would have a blast talking to that person.
Okay, let's finish up here. The golden principle of physics. Okay, physics is done with objects. You can't do physics with concepts. You cannot move concepts around. The irrational concepts that mathematicians treat as objects and move around are those on your bottom right. You can choose any one of those, and those are all irrational terms because they are concepts which are treated as objects. That's where the problem is. Okay? Comments, questions?
There is a lot of comments and questions, but I think we're gonna have to do it differently. I think we're gonna have to reserve a day where people just ask questions and we just talk to them directly because your presentations is too long.
Well, we'll try and cover some. Some of this is, remember, it's a recap of the month.
Yeah. But I'm just saying, like, to answer people's comments, sometimes it really just should be the whole day.
Okay, here's our science critic. Okay, we'll get to him. Okay, and here it is. He said that essentially he said that magnetism has been explained by our great white fathers. Let's find out if that's true. Give me a second here. Okay, here it goes. Listen carefully. The questions and issues to be addressed in this rebuttal include: does the mathematical establishment have any idea whatsoever what physical mechanism underlies magnetic attraction or repulsion? And do the mathematicians have an explanation of the causes that underlie magnetism, or merely a description?
Well, that comes down to magnetic domains. When magnetic domains are aligned, they produce a magnetic field. And when you produce a magnetic field, that can exert a force on other materials. Yes, magnetism is a difficult thing to understand. It can seem like magic, but there are rational explanations for it.
Do the mathematicians have rational explanations for it?
Wait, he didn't explain it?
No, he didn't explain. He just said, "Oh, there are explanations out there." Okay, let's find out. Let's find out. And I'm gonna just bring testimony here. Okay, I'll let the physicists, the mathematical physicists, tell you in their own words. Okay, here's the first one. This is Mr. Richard Feynman. Some of you know him. He was a Nobel Prize, 1965. And this is what Mr. Feynman had to say about how much he knows about magnetism. And I think some of you heard this, but somewhere. But here it is again, one more time. Here it goes. Listen carefully.
If you get hold of two magnets and you push them, you can feel this pushing between them. Turn it around the other way and they slam together. Why are they doing that, or how are they doing it?
You're asking.
I must say, I think that's a perfectly reasonable question.
Of course, it's
ask.
a reason. It's an excellent question. Okay. But the problem that you're asking, you see, when you ask why something happens, how does a person answer why something happens? Now, when you ask, for example, why two magnets repel, there are many different levels. It depends on whether you're a student of physics or an ordinary person who doesn't know anything or not. If you're somebody who doesn't know anything at all about it, all I can say is that there's a magnetic force that makes them repel, and that you're feeling that force. I'm not answering your question, but I'm telling you how difficult the why question is. You have to know what it is that you're permitted to understand and allowed to be understood and known, and what it is you're not. Well, I just have to tell you that's going to be one of the things you'll just have to take as an element in the world, the existence of magnetic repulsion or electrical attraction, magnetic attraction. I can't explain that attraction in terms of anything else that's familiar to you. So I'm not going to be able to give you an answer to why magnets attract each other, except to tell you that they do. But I really can't do a good job, any job, of explaining magnetic force in terms of something else that you're more familiar with, because I don't understand it in terms of anything else that you're more familiar with.
Okay, so that was a great explanation by Mr. Richard Feynman, how a magnet attracts and repels another. Great explanation. Didn't you think so? And so I don't know what this fellow is talking about, because Richard Feynman didn't know that in 1965. Here is another fellow, and he's from UCLA. This is today, okay? And this is the explanation, quotation on that, of how a magnet attracts another, okay? Listen carefully here. Give me a second. here.
Magnets. One magnet either repels or attracts another, and nobody knows why. Except you, after watching today's video. Naturally occurring minerals were found to attract iron in the ancient Greek region of Magnesia, and so were aptly named for the area. And these rocks were found to either attract or repel one another. One way to understand magnets is through magnetic domains. You see, unmagnetized iron metal is composed of a whole bunch of tiny little crystal magnets called domains. And they're randomly oriented, pointing in all different directions. But magnetized iron has all the domains aligned. That is, it has a north side and a south side. And that orientation is what allows it to become a magnet. During the magnetization process, the domains flip suddenly. This flipping can be made audible. I have here a small piece of nickel, which I'm placing inside of this coil of wire. Any rapid changes in magnetic field will sound on this speaker here. I also have a very strong magnet, which I placed on the north end of this little magnet. When I bring it close to the nickel, listen. Do you hear the domains flipping? And there you have it, a new magnet. This iron paperclip can be magnetized by this magnet. The magnetic domains in the paperclip can be destroyed by heating. And the magnetism is lost. Besides iron, cobalt and nickel are also magnetic. Their proximity on the periodic table lets you know that magnetism is a result of electron valence. That is, all magnetism is caused by electrons. This coil of wire with a looping current is acting just like a bar magnet, causing compasses to point out of north and into south. Out of north and into south. Could it be that the electrons orbiting the iron atoms are the net cause of magnetism? That is, could it be that circling electrons are causing the magnetic field? In 1915, Albert Einstein and von der Haas ran an experiment to check that it was the orbiting electrons that caused magnetism. The results were negative. Later on, it was discovered that electrons had a property called spin. That is, the electron was spinning as it circled the nucleus. It's the alignment of these electrons' spins that results in the magnetic properties of iron.
Okay, so what did he say? He says the only reason that a magnet attracts another is because the electrons spin. Okay, so the electrons spin. How does that make one magnet attract another? He never explained. He just says the domains are aligned in each magnet. Okay. He said the electrons spin in each magnet. Okay. How does that produce attraction? So he never explained how a magnet attracts another, just like Mr. Richard Feynman said. Yeah. So this science critic, he doesn't understand that. He thinks he's got an explanation, or that there must be an explanation out there. No, they don't have explanations. Not a single invisible, intangible process, right, out there, or phenomenon out there can be explained by any mathematician on Earth, and has never been explained in the last 3,000 years. The only way you're going to explain it, if you introduce the invisible, intangible objects that mediate those transactions. Period. And if you do not think that there are invisible, intangible objects out there that serve as mediators between objects, meaning you're going to do action at a distance, all you're doing is black magic. You're saying this one moves here and it moves the other one over there without anything in between them. Simply what? Because you can't see or touch it. And that's the situation right now. And that's why these people cannot explain it. And that's the only reason.
Care to.
Yeah. No, because they're not into that business. They're in the business of doing equations. They think that's science.
Well, really, they're in the business of dangling keys in front of you with authority, making you think that they explained it and saying, oh man, they must have. It sounds like they understand it because I'm too dumb to.
Okay, so one fellow says the thing that connects every atom to every other atom is invisible and intangible. I remember when you used to say you can only do physics with physical objects. Yeah, see, this fellow believes that an object is that which is visible and tangible. And again, if you've got that irrational notion of what an object is, if you have that irrational definition, of course you're never going to discover gravity.
Well, it's rational until tested.
Yeah.
Until you put it to the test, it's
rational. But that's what I mean.
It makes sense.
You're going to be testing the definition. You're saying, look, that definition is irrational. You can't use that in physics.
I wouldn't say it's irrational. I think it's just not good enough. Because it's understandable. You can understand what he's saying.
Yeah, but
in that sense,
you know why it's irrational? Because of the following. It's irrational because people say, okay, I'm going to go to the lab and run a test. Okay. What test are you going to run? What test are you going to run, first of all, because you're trying to test or trying to run an experiment on something that's invisible and intangible. That's the first issue. But then you have another issue, and that is that you need a second object to do the seeing and touching. That already makes it irrational. I mean, it should be clear that you cannot use a second object to define one object. Mm-hmm. Okay, and so you have all these, and it's like, I got to run a test. If the asteroid does not hit the moon, neither one is an object until they touch, until they touch each other. And so, I can't see that table on the other side of the universe that the Klingon has. So because I can't see it, it's not an object. So, from every point of view, this is an irrational definition. We can use it in ordinary speech, but not in science.
I still don't like the term calling it an irrational definition because it's rational because you can understand it, but it's just not a good definition.
I'm saying it's an irrational definition because you need two objects to define one. That should be clear that you cannot use it in science, and so on. Anyways, so this is what I answered this fellow. Thing is not that which is see, touch. Thing is that which has shape. And those are synonyms there. And thing, see, some people confuse thing with exist. No, a thing is not a synonym of existence, which is what David Hume and Immanuel Kant thought about.
I mean, it should be. Really.
Yeah, well, in everyday life, yeah.
No. I mean, like, why should we even talk about objects which don't exist? That's just a human problem, really.
Yeah, but we're not talking only about objects that don't exist. We're talking about objects that, like a square, which we can imagine. Yeah, it doesn't exist because it doesn't have location.
If you had people that only knew logic, didn't know sarcasm or poetry, they would only do physics with things that exist.
Dogs, cats, all they see is what they see and touch,
Yeah.
But then you have objects which you could say exist, like the rope that interconnects two atoms. We can't see or touch it. It doesn't have location. Well, under the new notions that we have with the rope model, then location is a different kind of word that you really need to define, because we always define position, location, all those terms, always using atoms. We always thought of something that has location, only that which is made of atoms. Now we're saying, look, the rope is not made of atoms. Does it have location? Well, there is distance between two ropes. So in that sense, you can say the rope exists
with relation to itself.
Yeah,
it gets real weird.
So it gets weird. You gotta redefine these terms with the rope model.
Unless you just straight up assume that there's at least two threads in the universe.
Yeah, and that's another issue. You can make that assumption that there's two threads in the universe or more, and in that case, all threads exist, and you can continue with that. Anyways, here's another fellow says, in order to have shape, an object would need to retain shape for more than one frame of a movie. And he says that you need to see the sun in at least 2 frames in order for it to have shape, because it changes shape from one frame to another. It's absolute nonsense. This poor fellow, he never went to kindergarten. He should go back to playing with blocks again. Yeah, you don't need 2 frames of the movie for shape. Shape is a static concept. It's not a movie, and you should see it in a single frame. So if I take a snapshot of the sun, and for that snapshot, the sun has shape. And he said, what is the shape of it? Wrong question. The question is, does it have shape? Okay, I can get a whole bunch of atoms that form air, and the question is, does it have shape? Not what is the shape of air? That's an irrational question for what we're trying to answer here. The question is, does it have shape?
I got a quick question here, just for clarification.
Yeah.
Really, someone
Okay.
asked, "Isn't the rope one rope the entire world consists of?"
Huh?
Isn't the rope one rope that the entire world consists of?
No, one thread, not one rope.
Yeah.
Okay, it's the
Clarified.
thread. Yeah, we should not confuse the thread, the single thread, with the rope. Rope is what lies between 2 atoms. It's always straight because it's taut, okay, and
What
it
is
torques.
the thread?
The thread, on the other hand, is what makes up the atoms and the ropes, and also forms the magnetic fields. A bunch of threads together, that's what we call the magnetic field. A bunch of threads moving, okay, that in general terms, okay. And here another fellow says, I think it's the same fellow, you've never established the existence of any such thing as a physical object, as a contiguous block distinct from the rest of the universe. He thinks that there's a single block of matter, infinite block of matter in the universe, and that there's no separation between them. Yeah, the separation is known as space. That's what chops up pieces of objects, one object from another. It's space that chops it up. Without space, it would be a single block of infinity, and that's not even an object. Because if you can't see the shape of it, if you cannot imagine the shape of it, because this thing is an infinite block, then you don't even have an object. Okay, an object that which has shape. So yeah, and then he says an object is an imaginary concept. You see what happens when people don't define their terms? We don't know what this fellow thinks of as an object. We don't know what he thinks of as a concept. Then he says 99.9% of the atom is empty space. I think the space between your ears is 99% empty. Okay? Only the mathematicians came up with this notion that an atom is mostly empty space. We say something different. An atom is mostly ropes and threads, okay, which are intangible, and therefore it seems to the mathematicians as if it were empty space. The empty space is between your ears, okay, so never say that an atom is mostly empty space. And he says, our senses can only perceive motion. Well, I'm sorry to hear that from you. I can perceive objects. Here's an object, I can perceive it, and I don't have to see it move. Okay, I can see a picture of it.
I mean, he's not wrong if you.
But he's talking about nonsense because he hasn't defined any of his terms. He doesn't know what motion is. Can this bean brain here define motion? Okay, has he ever defined the word object, the word motion? Okay, he hasn't. So talking to him is talking to a wall. Okay, because he doesn't have any idea what these words mean. He's never defined them. Okay, he says an object is a concept. I mean, what can you possibly understand? There's only 2 kinds of words, objects and concepts, and hopefully they're not synonyms.
That's true. Our senses can only detect motion, I guess.
Then he says, atoms are not static bowling balls. Well, thank God. Yeah, so what? I can take a picture of an atom, and at that moment in time, I can see a picture of it, and that is an atom. Right now, I don't have to see, the word atom does not include any motion in it. There is no motion involved in the word atom. Okay. Now, do electrons move? Yeah. If you're going to use the quantum model, do protons move? Yeah, they spin and all that stuff. We don't care about all that. Can you take a snapshot of an atom, assuming you're an atom man, and get one little ball called the electron next to a proton ball. Yeah, that's what the atom is according to quantum mechanics. A proton ball next to an electron ball. And that is a static image. You don't need to have any of those two move in order to say atom. Okay, atom does not include verbs, does not include motion. And I guess this poor fellow does not understand that. He's never learned the basics. I don't think he even went to kindergarten. He never played with blocks.
I think he did. That's the problem. That's where you.
Or he never graduated, I guess.
No, he did. That's the problem.
That's
what they
and
teach
then
you.
he says here, what did he say? The moment that an atom stops moving is the moment it ceases to exist. He never defined the word exist, so we don't know what he means by exist. So we define for him an object with location. Location is a static concept, so is the word object. So exist is a static concept. There is no motion involved in the word exist. If you cease to exist, the object has morphed into space, meaning nothing. It means it lost length, width, and height suddenly, spontaneously. If you can explain that process to me, then we can talk about ceasing to exist. Okay, again, because this poor fellow, he doesn't define his terms. He goes around in circles chasing his tail. Okay, and another fellow says, the electromagnetic ropes get tangled because, oh no, I think it's the same fellow says, the electromagnetic ropes don't get tangled because they lack the property of touch. How convenient. No, it's not that it's convenient. It's that if you're going to define these terms and you're going to have an assumption on which to base your theory, it had better match, to some degree at least, what Mother Nature has out there. And we can't see or touch what's underneath the spoon. When this spoon falls, right, it falls to the ground, and we're saying that there's something here that we cannot see or touch. It's not that it's convenient, it's that I have to define the word in such a way that, in other words, I have to identify the object that is here, which matches Mother Nature's specification. And hopefully this is invisible and tangible.
It's
if
not
you
so
say
much that it's convenient, it's what it is. It's the other
and
way
this
around.
guy says, no, it's got to be visible and tangible. Well, it ain't. I'm sorry to tell you, it's not visible or tangible. And if you say there's nothing here because you cannot see or touch it, you're an irrational individual. Okay, if you cannot see or touch it because you have an irrational definition of the word object.
The one caveat to that would be is if there was a relay, something shooting from the wood to my finger and my finger to the ground. There, maybe. That
but
might be
I
a
mean,
possibility.
what we're saying here is that there is something here. If you say there is nothing here pulling this down,
you didn't hear me. You didn't hear me. I'm saying it could be that whatever is pulling this to the ground is being relayed between it to my hand and my hand to the ground.
Yeah.
So it's not that my hand is going through things. It might still be tangible, but it's a different mechanism. By the
yeah, but there's still something here.
Yeah, but it's from the wood to my hand to the ground.
Correct.
So what I'm saying is my hand isn't going through things, and that's in that theory.
Okay, but all I'm saying is there's something here. You can't see or touch. There's something here or up here. I mean, you can use particles. I don't care. But there had better be something up here or down here. If you're saying there's nothing there because you can't see or touch it, first of all, you are what's the idiot is the word. If you go to the lab to try to prove it through some experiment, that's the first one. And the second one is if you do it, if you explain your theory without putting an object here, which is invisible and intangible, you make that assumption, then you're doing it with black magic. You're saying that the earth pulls on this or something pushes on it, but there's nothing there. You're just doing it through black magic. You're through what is it called? Action at a distance. That's what you're doing. Okay. So yeah, it's all these people who want to do see and touch. And again, fellas, you seem to be describing the ropes as if they are physical objects. Yeah. Yet you also say it's an invisible medium. Yeah. How can you say that your mechanism is direct and physical? Because physical means that which has shape. These so-called ropes are not visible. Again, it's the visibility these people have in their mind. If it is a physical mechanism, asking what the rope is made of or how many ropes there are would absolutely be a pertinent question. Yeah. No, because they are intangible. Therefore, you can have gazillions of rope in a teeny little bitty space like that. So it doesn't matter if they're intangible, if they can't touch each other, you can have many, many gazillions of ropes superimposed, which is exactly what quantum does in its world. It says that all these atoms, all these particles, they superimpose. So there's no difference there between the official version and us. If you have some other version, we'd like to hear it. If they don't superimpose, if they're not intangible, then I don't know what you propose instead. Please propose something.
I think that to what he's saying, he was confusing having shape and it being visible. How can something have shape if it is invisible? How can you have an invisible shape? I guess that was a question.
And the issue is that shape has nothing to do with visibility.
Yeah.
That's the issue. The issue is that tangibility and seeability or visibility, right? Those are irrational definitions that mathematicians have used for 3,000 years. We're saying that's the irrational definition. The correct definition, or the scientific definition, is that which has shape. Does that mean that you can see it or touch it? No, because visibility and tangibility have nothing to do with shape. The moon had shape before we were even here on the planet, any human. Okay, so there was shape already. Mother Nature deals with that.
No, but it goes to a deeper issue where it becomes, how can I conceive of something if it is if it has shape but it is invisible? What we do, we give it color. Very simple.
Yeah, it doesn't matter.
It doesn't mean just so that we can understand the theory is what I'm saying.
Yeah, but the issue here is the following. I can conceptualize a shape like a rope. I can imagine a rope. I can see a rope here, right? This one you can see and touch, and it's got colors, etc., right? I don't need that. I can imagine one. I can imagine a rope. Okay, so someone says rope, and he doesn't have to show me a rope because I already know what the word rope means. And I imagine, okay, I think I know what you're talking about. Mm-hmm. You're talking about a braided pair of, the strands. Okay, and so I don't have to see it. I already visualize it in my head. I know what he's talking about. Okay.
In reality, it's invisible. But we can give it color in our heads just so we can understand each other. I guess that's
we have never seen an atom, a hydrogen atom. No one has ever on Earth seen a hydrogen atom. That's why no one can, in quantum mechanics, no one can draw a hydrogen atom. Whatever they draw is for sure irrational and wrong, because they cannot explain why that electron bead does not spontaneously fly out of the atom or fall into. I mean, it just rolls around or is on different sides of the proton. Why? Why does it fall? Why does it run away? And so nobody can draw for you a hydrogen atom because no one has ever seen a hydrogen atom. Does that mean that a quantum mechanic cannot, one of these mainstreamers, that they cannot give you a picture of a proton and an electron next to it? In fact, you'll find them all over the internet. Look up the word atom and you'll find a little ball in the center for the hydrogen atom. Little proton in the center and a little bead next to it with a little circle around it. That's everybody conceptualizes it. So to say that you cannot have a shape without having seen it, that's irrational. Your expectation is irrational. Okay. Atoms are not static bowling balls. They are vibrating force fields. A field is a concept. So if you say that a field vibrates, it's vibrating a force field. It's a force field. May the force go with you. That's all I can say. Anyways, we're going to stop it here today. It's just gone too long today. Too much material. So we'll see you on Sunday, and we'll take some of the...
I did want to... I thought there was an interesting question there. It was real simple.
Last one.
Can a single atom be magnetic? One atom in the universe.
Yeah. In fact, the best way to answer your question is to show you graphically, right, a little movie of that. And a single atom can be magnetic, and that's how ionization works. But for that, I would love to show you. I'll put that on there. If I remember that, I'll try to remember the question. And what I'll do is I'll show you exactly how ionization works, and you'll see the magnetism, how it's a magnetic process at the atomic level. But for that, I need to show you, a picture's worth. In fact, a movie is worth 1,000,000 words. That's the way I look at it. We'll see you next Sunday, okay, coming up, and hopefully